Good morning, sir.
Now let us start the class now. So those who are present online, please take the screenshot of this one. So what is this Norton's theorem? So Norton's theorem explanation is similar to the Thevenin's theorem. What is Thevenin's theorem statement? Any student? Thevenin's theorem? Yeah.
Any complex circuit can be converted into a simple circuit.
So what is that simple circuit?
It's voltage and one resistor.
And one
Right.
resistance.
So what is the statement actually? Complex circuit means what Thevenin has mentioned, number of voltage sources or number of current sources or combination of both voltage source and current source can be replaced by single voltage source with series resistor. So after introduction of Thevenin's theorem, Norton has introduced the new concept, the new theorem. Okay. So what he is trying to explain? So the statement is similar. Any linear bilateral network consisting of number of voltage sources or number of current sources or combination of both voltage source and current source can be replaced by single current source with parallel resistor. So what Norton has mentioned, any circuit, any complicated circuit can be converted into a simple circuit. But what is that simple circuit right now? A current source with parallel resistor. Whereas the Thevenin's is voltage source with series resistor. So no, this is a statement. Any complicated circuit, that is circuit containing voltage sources or current sources or combination of both, can be replaced by single current source with parallel resistor, where the value of current source is I Norton's, that is Norton's current. IN stands for Norton's current. So what is the definition of Norton's current? Any student read out here?
Short circuit current flowing through the terminals A and B.
Right. So remember all of you, short circuit means you just imagine as per our subject, it is the maximum current. Short circuit is nothing but maximum current. Open circuit in the sense maximum voltage. So what is this Norton's current? Short circuit current flowing through the terminals A and B. You know what do you mean by the word short circuit as per our subject? How to do the short circuit? You place the copper wire. Yes or no? Short circuit means placing the copper wire between the terminals. And one more, yes, once again you read what it has written here. What is Rn stands for Norton's resistance. Norton's resistance formula definition is equal to Thevenin's resistance, as we have done yesterday. What is Thevenin's resistance formula? Equivalent resistance seen from the terminals A and B when all the sources are removed. So Norton's theorem, 80% explanation is similar to the Thevenin's theorem. Only difference is Norton's theorem has got single current source and parallel resistor. And Norton's resistance is equal to Thevenin's resistance. And what is the name of the Norton's current formula? Norton's current is the short circuit current flowing through the terminals A and B. Okay? No. Right. Is any other classes going on? Because very less strength present today. Anyone please tell me?
No, sir.
Okay. Right. Okay, right. So Norton's theorem statement is this one: any complicated circuit can be converted into simple current source with parallel resistor. So we have to explain in these terms. Now we'll take the problem on Norton's theorem. Okay. Now that problem is important. Let me share. So I'll be sharing the image. So all of you, new circuit is visible on the screen. All students.
Yes, sir.
Okay, right.
Yes, sir.
Okay, see, we are having the simple circuit here. Anyone tell me, what is the indication? Using Norton's theorem, we have to calculate current flowing through which resistor? Tell me all of you by seeing the question.
Load resistor.
1.5.
1.5. 1.5. Now, by seeing the circuit, what idea you are getting? Which technique you have to use?
Mesh analysis.
Mesh analysis. Very good.
Mesh.
Very good. Yes, for verification, all of you, whether it is Thevenin's theorem or Norton's theorem, for verification, you can do the this mesh analysis. You will get the same answer. So our aim is to calculate one current flowing through 1.5 ohms using Norton's theorem. But if in the examination, when they mention Norton's theorem, you have to use the Norton's theorem procedure only. Now, anyone tell me, sir, using mesh analysis also, I will get the answer. But why I have to study the Nortons or Thevenin's theorem? Anyone tell me? If I'm using mesh analysis, what is the disadvantage? Mesh analysis cannot be used for complicated circuits, the circuits which are having minimum 50 meshes or 100 meshes. We cannot create 50 mesh currents. It is complicated process. So these circuits which are having high number of meshes, those circuits can be easily solved by Thevenin's or Norton's theorem. Okay, now using Norton's theorem. So what is the first step? Anyone? Same steps here also. Read out what is the first step.
Remove load
Remove the load resistance RL
Okay,
is equal
we have
to
removed the,
RL
yes, similar to Thevenin's. If you know the Thevenin's theorem, Norton's theorem is also similar. Last step is different, right? Okay, we have removed the load resistor. And next, step two. Step two, read out one more, student. Calculate Norton's current. Calculate, yes, not calculate Norton's current. Okay, what is that Norton's current? How to calculate? By short circuiting the terminals A and B. Terminal means end points. So here if you see, sir, I want to calculate Norton's current. How to calculate Norton's current? Another name for Norton's current is short circuit current. So Norton's current, calculate Norton's current by short circuiting the terminals A and B. Short circuiting means what? You take a copper wire and place the copper wire between A and B. Here I have shown. Okay. Now the current flowing through this copper wire is nothing but short circuit current or maximum current, and the another name is Norton's current, IN. So all of you, is it clear? So what is the Norton's theorem procedure? Remove the load resistor. Okay, load resistor is removed. And in the place of load resistor, what we have to do? Anyone tell me? Short circuit the terminals A and B. Short circuit the terminals A and B. Okay, I got the clarity here. It is short circuited. Okay, I can calculate the current. Now, you tell me, by seeing this circuit, how many meshes we are having? All the students. Now we have short circuited.
Two
Short
meshes.
circuit, yes. Short circuit means close that end point with the copper wire. Okay, two meshes. Okay, so immediately I want to calculate the Norton's current. Anyone tell me, what is the formula for Norton's current now? Norton's current or short circuit current? This short circuit current or Norton's current is flowing in which mesh? First mesh or second mesh?
Second
mesh.
Second mesh.
We say that, yes, we say that IN is nothing but Norton's current, short circuit or maximum current flowing through the terminals A and B. Now I am applying the KVL. You people are perfect in KVL. 12 is equal to 2 into I plus 6 into I1 minus I2. We get two equations. Okay, we can solve the two equations in Calci, all of you. So what are the values we are getting? Tell me, all of you. Anyone read out?
equals to 3
I2 is equal to 2 amperes. Okay. Now, but my aim is to calculate the Norton's current or short circuit current. Now you see the circuit. Short circuit current is flowing in second mesh and its arrow mark is shown downwards. Always it is taken downwards, Norton's current. You tell me I2 and IN both are in same direction or opposite direction?
Same direction.
Same direction. Here also it comes down and both are in same direction. Therefore, since ISC or I Norton flowing in second mesh, I2 is equal to Norton's current equal to 2 amperes. Yes or no? Because we got mesh 2 as 2 amperes. Is it clear, all of you? So what is the Norton's theorem? It is also similar to Thevenin's, but in Thevenin's what we do? Open circuit voltage, Thevenin's voltage. But in Norton's, what we are going to do? What is the formula for Norton's current? Anyone? Short circuit current flowing through the terminals A and B. What is Norton's current? Short circuit current flowing through the terminals A and B. Okay. So remove the load resistor and short circuit the terminals A and B. The current flowing through the short circuited terminals is called the Norton's current. Okay. So you are going to use the mesh. Now we'll going for the step 3. Anyone tell me step 3 what we have to do? Norton's circuit means not okay, I'll share this one. What is Norton's equivalent circuit? Anyone? Norton's equivalent circuit means what? Any circuit will be replaced into the Norton's equivalent circuit. On the screen, what we are having? A current source with parallel resistor. Yes or no, all of you? Okay. Current source we have calculated. What is the Norton's current value we got just now? 2 amperes. Now what is our next target? Anyone tell me?
Resistance.
Norton's resistance. Norton's resistance. which is also equal to Thevenin's resistance. So same formula and same method what we have used. Okay, let us go for this one. Yes. Now new image is available on the screen. Okay. Now all the students, step 3 is what? Determine Norton's resistance. And what is there in the bracket? Norton's resistance Rn is equal to Thevenin's resistance. Rn is equal to Thevenin's resistance. So yesterday as I mentioned. So now what is the formula for Thevenin's resistance? Anyone? Equivalent resistance seen from the terminals A and B when all the sources are removed. So how many sources we are having in the circuit given? Only one voltage source. So voltage source remove means what? What is the meaning? Anyone tell me? Voltage source
Replacing
remove.
it copper wire.
Very good. Voltage source remove means replace the voltage source by the copper
The
wire.
copper
Okay?
wire.
Yes, copper wire here I have placed. I have removed the voltage source and I have placed the copper wire, which is nothing but, sir, why you are doing like this means when you replace the voltage source with copper wire, then only the voltage value is equal to 0. Remove the voltage source means voltage should be 0. Remove the current source means current source value should be equal to 0. So current source will be 0 under open condition and voltage value will be 0 under short circuit condition. Okay. Now you see all of you. Now the biggest challenge is now what is Thevenin's resistance or Norton's resistance? Resistance seen from this arrow mark is important. Resistance seen from the terminals A and B. Equivalent resistance. Anyone tell me what do you mean by the word equivalent resistance? Any student? Equivalent resistance. So if I am observing the circuit from A and B, the combination of these three resistors is called equivalent resistance. Is it clear? Equivalent resistance seen from the terminals A and B when all the sources are removed. So now you see all of you. So if I'm watching the circuit from these terminals, what is the assumption? How these three elements are connected? Whether they are connected in parallel or series, we have to check, all of you. So first, all the students, if I'm watching the circuit from A and B, first I have to reduce the circuit from opposite end, as I mentioned yesterday. So opposite end, which resistor you are having first? Anyone tell me? 2 ohms.
2.
And
ohms.
next which resistor we are having? 6 ohms.
6.
Okay.
6 ohms.
So first we have to check whether 2 and 6 are connected in series or parallel. So how to explain that one? Imagine current is coming from the terminal A. That current flows through 3 ohm resistor and that current comes to this junction or the node. Then what will happen to the current? Tell me all of you. Is the same current flows through same current flows
If
through
the
2 and
current
6?
divides into 2, then it is in parallel.
Parallel. Yes, very good. So assume that current is starting from the terminal A, that current is flowing towards the junction and that current is dividing here 2 and 6. So the current, these two resistors are connected in parallel. If the current divides, then the resistors are connected in parallel. So first we have written 2 parallel 6. Now most important thing, all of you, don't do 3 and 6 are in parallel. So remember the one logic. What is the logic? If you are watching the circuit from A and B, you reduce the circuit or solve the circuit from opposite end. You cannot solve from this 3 parallel 6 or 3 plus 6. That is wrong. So if what is a universal logic is nothing but if you are watching the circuit from A and B, reduce or solve the circuit from opposite end. Opposite end, which resistor is visible first? 2. And what is the next resistor? 6. So first you solve only 2 resistors at a time. We cannot solve 3 to 4 resistors at a time. We have to take only 2 resistors at a time and check whether they are in parallel or series. 2 and 6 are in parallel. I'm not explaining by connection. We assume the current is flowing. If the current divides, those two are in parallel. Okay. 2 parallel 6. Now tell me the formula when 2 resistors are in parallel. Yesterday I've given. 2 resistors are in parallel. Remember
1
the
by R equivalent 6
R1,
ohms, 1 by R1
R2
plus
by
1 by
R1
R2.
plus
Okay.
R2.
So 1 by R equivalent equal to 1 by R1 plus 1 by R2. That is when 2 resistors are in parallel. 1 second. When 2 resistances are in parallel, okay, total resistance is direct formula R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. Therefore, R equivalent equal to R equivalent means Norton's resistance. 2 into 6 by 2 plus 6. So first we have written 2 parallel 6. Now again we have to draw the circuit. 2 parallel 6 how much? 2 into 6 by 2 plus 6, 12 by 8. 12 by 8 if you are doing 1.5, we get 1.5. Now all of you see, sir, how to place this 1.5 is the question. So 6 ohm resistor is connected to 3. Yes or no? How 6 ohm is there, vertical or horizontal?
Horizontal.
6 you see in the circuit. 6
Vertical.
vertical. So what is the last resistor connected to 3? It is 6. Combination of 2 and 6, we got 1.5. How to place 1.5, horizontal or vertical? See, vertical, you go for this last resistor connection. So as it is, I have placed in the place of 6. The combination is 1.5. We have placed. Now, all students concentrate and tell me how to tell these two are connected in series or parallel. Anyone tell me how to assume what we have to do?
Current is flowing
Yes,
point
assume. Yes.
same.
Very good. So assume first the current is flowing from the A. So that current starts from A, it flows to 3 and it flows through 1.5. Is the current is dividing or not dividing? Current is dividing. Current is not dividing. If the current is not dividing, both resistors are in series. If the current is dividing, they are in parallel. So series means what, all of you? Series connection means what? R1 plus R2 we know. So
R1 plus R2.
Yes, 1.5 plus 3. So I have written here plus 3 here. Understood all of you? 12 by 8 plus 3. So you can write from starting or you can write at last. So what is the value you are going to get? 1.5 plus 3 ohms is nothing but total 4.5 ohms. Again, this is the total equivalent resistance seen from the terminals A and B. Rn is equal to 4.5 ohms. Okay. Now, what is step 4? Similar to Thevenin's theorem. Represent. Yes, one student read out. Represent Norton's equivalent circuit.
Represent Norton.
Anyone tell me what is Thevenin's equivalent circuit? Any student tell me? What is Thevenin's equivalent circuit? Voltage source with series resistor. But yes, what is Norton's equivalent circuit? Anyone tell me?
Voltage source with parallel
resistor.
Wait, Norton's equivalent means current source. Norton's means current, remember. Thevenin's means voltage source. Norton's equivalent circuit. Now you tell me. Current source, this is arrow mark, no. Arrow mark is there means it is current source. Current source with which resistor? Parallel resistor.
Parallel.
So all of you, where the value of current source is how much? Norton's current, and the value of resistor is Norton's resistance. Right. Come on. Yes. Don't do any personal chatting in the chat box. Okay. Right. Any question is there, you just upload. Now, current source, 2 amperes current source is in parallel with the resistor. Now, this is the Norton's current. We have calculated Norton's current. We got 2 amperes. Now, what is the last step? Similar to Thevenin's theorem. What we have to do? Reconnect the load resistor. Reconnect the load resistor to which circuit? Norton's equivalent circuit. So what is the load resistor we have removed? In the first case, 1.5. Now I am connecting 1.5. Okay. Now all students, many students have, if you are not understanding the nodal analysis, go through that nodal analysis video. Okay. Now you see all of you. How to solve this circuit? I am asking all students, see the circuit and tell me. Reconnect the load resistor to Norton's equivalent circuit. Okay, I have connected the load resistor 1.5. Now by seeing this circuit, what method you are getting in your brain?
Nodal
Very good, very good. See, the first thing is nothing but your friends are also studying in other colleges. You ask them when to use nodal, when to use mesh. I am confident that no student will be confidently explaining. Okay. The first thing in our BW subject is when I have to use mesh analysis, when I have to use nodal analysis, we should know. That makes the 50% subject clear to everyone. So we got the current source. Okay, current source we got. Now I have to go for nodal analysis. What is my aim? Anyone tell me what I have to calculate? We have reconnected the current flowing through 1.5 ohms. Okay. Yes, that we'll do later on. But once you see the current source, go for nodal analysis. How many nodes are there? Anyone tell me?
One node.
Node is a combination of minimum 3 elements.
Three elements.
So three elements where they are joining, that point is called node. So here their three elements are joined. It is called node. At the node, which energy is present? All the students, voltage or current? Voltage. So I have written here voltage. You can call it as 1 or you can directly write voltage. So what is the equation? What is the equation? Tell me. Current source is entering or leaving the node?
Entering.
Entering. So 2 is equal to V by 4.5 plus V by 1.5. V by 1.5. And V you taken common and we are getting the value. You also check the value. V is equal to 2.257 volts we got. But what is our aim? Is our aim to calculate node voltage? No. With the help of node voltage, we calculate the current flowing through 1.5. Anyone tell me how to calculate current flowing through 4.5? Generally, I'm asking. How to calculate current flowing through 4.5? 4.5 is connected to node. So node voltage. So I is equal to V by 4.5. Understood, all of you? Current flowing through 4.5 is I is equal to V by 4.5. Now you tell me current flowing through 1.5 ohms. How much? Formula.
V by 1.5.
V by 1.5. So here we have written current flowing through 1.5 ohms is I 1.5. Generally we write is equal to V by 1.5, which is equal to 1.504 amperes. 1.504 amperes. So it is the current flowing through the load resistor using Norton's theorem. Sir, what is the proof that the answer I got is right or wrong? So all of you, what we have to do, tell me anyone? The same problem you have to do with which method? Mesh analysis. And you will get this same current. Okay. I2 value, you have to get the same value. Let me share this one once again. The circuit. See, these circuits, whatever we are doing, that's enough. No need to see any textbook. One day I will share the textbook circuits. Any circuit you see, you use the techniques and check the answer. Okay, that is what the practice. Okay, now all of you come back for last time. This is the circuit. So what is the current flowing through 1.5 ohms? Anyone tell me what is the value we got? 1.504. Yes or no? So even if you are using the mesh analysis for verification, mesh analysis I1 and I2, what I2 value should be equal to 1.504 amperes. Okay. Now, what is the Norton's theorem procedure? Come on, anyone student, raise your hand and just go on for the explanation. Who is perfect? Step by step. You see and tell what we are supposed to do. Norton's theorem. Okay, I'll tell. Yes, listen everyone. Remove the load resistor. Okay, load resistor is removed. That circuit you have to show. And in Norton's, what we have to do? Thevenin's means we calculate open circuit voltage. Now I'm asking one small question. What is the formula for Thevenin's voltage? Anyone? Raise your hand and tell me. Thevenin's voltage, what is the formula? Open circuit voltage present between terminals A and B. Open circuit voltage present between terminals A and B. Okay. What is Norton's current?
Short circuit.
Very good.
Short circuit.
Today at 4 o'clock, I'll keep one online exam, which will be objective type. Okay. Without preparation, everyone has to write. I will see how much you are listening without preparation. Okay. 4 o'clock, it will be there. Is it okay, all of you?
Okay, sir.
Okay. Online objective type. Casual, just like fun, it will be there. It will be just like a game. All of you, that exam will be just like a game. You will see that one, how it will be there. Okay. Now, you have to enter your name and they will give you one certain code. I'll tell you that one. Okay. If possible, I'll keep today. If possible, I'll keep today. Okay, right. Now you see, yeah, in that one, questions will be like this. What is the formula for Thevenin's voltage and what is the formula for Norton's current? Norton's current formula, come on, tell me. What is Norton's current? Short circuit current flowing through the terminal.
Through the circuits A and B.
See, current always flows through the wire. Voltage will be present. Okay. So current, short circuit current. So I have done short circuit here. Short circuit means what? All of you tell me. Placing the copper wire. All of you remember. Placing the copper wire. Okay. So in your house, how to do short circuit? I'm telling now. You take one small copper wire. And in your house, you got switchboard, all of you. Switchboard. How many holes will be there? Let us say 3 holes or 5 holes. 3 holes, 5 holes. Okay. 2 holes also will be there. So in 2 holes, you keep the copper wire. Immediately your house will be under short circuit. Entire power supply will be off. Okay, if you want to test, you can try at your own. Okay, okay, please don't try. Okay, right. So you take a copper wire and place in the 2 holes. Then what's going to happen? Copper wire is short circuiting. Short circuit means which one is 0? Voltage is 0. Therefore, voltage is 0, but maximum current will flow. Right. So short circuiting means placing the copper wire. We have short circuited. Immediately, which method we have to do? All of you know by seeing this circuit.
Mesh analysis.
Mesh
Mesh
analysis. We get I1 and I2, but short circuit current is flowing in second mesh. Therefore, Norton's current is equal to 2 amperes. So 2 amperes. So what is the next condition? Step 3 is all about calculating the Norton's resistance. This is very much important. Now here one simple question I'm asking. Tell me, if I'm watching the circuit from A and B, from which end I have to solve the circuit?
From the other
Of
end.
other end, that is 2 and 6
Which
at a time.
Ohms. 2 and 6.
At a time yes, at a time I can take 3 resistors to solve. Can
No.
I take? No.
No, sir.
Chepan, one student is asking question.
Can you repeat step 2, sir?
Step 2, yeah, 1 second. 1 second, just wait. Yes. See, step 2 is calculation of Norton's current. How to calculate Norton's current means by short circuiting the terminals A and B. Terminals A and B, you see the previous circuit, A and B are like this, open. Short circuiting the terminals A and B means place the copper wire here between terminals A and B. So I just place the copper wire. Okay, short circuiting the terminals A and B means placing the copper wire. Placing the copper wire means you just draw a line here between A and B. And now the current is flowing through this particular wire, which is called the Norton's current. But practically, what is our assumption? Current will flow in the mesh. So I2 is the current flowing in second mesh. I2 is equal to Norton's current. Is it clear? The student who has asked the doubt, the second point.
Yes, sir.
Okay, now you know what you have to do. You are watching this circuit. You apply this particular mesh analysis. You will get I1 and I2. Okay. We got I1 and I2 using the mesh analysis with the calci. Okay, I2. What is the value of I2? 2 amperes. So since short circuit current, where it is flowing at this end point. But that means it is also flowing in the second mesh. I2 is equal to IN. Therefore, we say I2 is equal to 2 amperes. IN is equal to 2 amperes. Okay, right. So any student, any doubt, you please ask. Don't hesitate to ask. Is it clear? The student who has asked the second point?
Yes, sir.
Right. Now, third point, we can calculate only 2 resistors at a time. Okay, 2 and 6 are in parallel because their current is dividing. We got 4.5 here. And now step 4. For both Thevenin's and Norton's, step 4 is what? Represent Norton's equivalent circuit. For Thevenin's, it is represent Thevenin's equivalent circuit. Now, what is Norton's equivalent circuit? Anyone tell me? Norton's equivalent circuit. Current source with parallel
Current source with a parallel resistor.
We got the values. We kept the values here. And what is the step 5? Very important. Reconnect the load resistor to Norton's equivalent circuit. Okay. Reconnect means I have placed the load resistor at terminals A and B. Now current source is seen. Which method we have to apply? Nodal analysis.
Nodal.
You get the node voltage, but we want the current flowing through 1.5 ohms. So I 1.5 equal to V by 1.5. 1.504. You do with the mesh analysis also same problem. Okay, right. Now you see all of you. Now I take you to the syllabus. You can take the screenshot of that one, the syllabus copy. BW subject, how many units we are having? We are having 5 units, all of you. New document is seen on the screen, all of you. Anyone student confirm me?
Yes, sir.
Okay, you can take the screenshot. 4 units you are able to see at a time.
Okay, sir.
4, you can take the screenshot. Now see all of you, whether we are doing these topics or not. See, introduction class. Introduction, what I have taken first today. Anyone tell me what is software engineering? Yes or no, all of you? What is software engineering? Anyone tell me the definition if you remember? Definition: practical application of scientific knowledge in order to design, implement, and to perform testing on software products. First day I mentioned. Then, Then we have taken new technologies. We have taken one project also, robotic snake. We have taken yes. All those things we'll do practically also, robotic snake, everything. Next, so all those things are nothing but introduction to the subject. What is the engineering? Okay. Now for the examination point of view, what you have to study for BW? What are the topics? Mesh analysis, nodal analysis, superposition theorem, Thevenin's theorem, Norton's theorem. That is your unit 1. So unit 1 is, you see all of you, DC circuits. DC means which current? Direct current. You tell me all of you definition I have given. The current which flows only in one direction is called DC current. DC current. Now you tell me, I have shown with animation. DC current is generated by dash elements. DC current, unidirectional current. In material also it is there. Battery, very good, battery. Okay, now all of you see what we have to study means all the students. Now please mute if the disturbance is there. Right, now you see all of you. This is the syllabus copy, and while preparing for exam, very first day, so many students have asked me, first 2 days, sir, send us this syllabus, we will start preparing. No, after class, explanation only you will understand what is there. Now you see all the students, unit 1. So what is this first topic? Electrical circuit elements. What is resistor? Introduction. Resistor definition, any one student tell me now. Resistor is a practical element which opposes the current, which decreases the strength of the current, and which passes the safe current. Okay, that definition. And now inductor, second one, inductor. Anyone tell me the inductor? I have taken the complete explanation of inductor theory. A copper wire twisted.
Copper wire twisted in a circular
Very good, very good. Inductor creates dash energy. Magnetic energy.
magnetic.
Yes. I have taken the applications also. One robot we have taken one day. How to move the robot program also we have written. Understood all of you? Yes or no? One robot, how to move the robot. So all those things are nothing but practical projects. So whatever the class I take, it comes with the BW class as well as the projects also. So one day of the end of this semester, you will be in a position to develop one robot. So this capacitor, all students, 1 second, right. This capacitor I have not taken because we'll study in second unit. Second unit you got the capacitor complete. So capacitor, if I take even in the first unit, everyone will get confused. So first unit, what is resistor? Inductor. Next, anyone read out voltage and current source. Voltage source means battery, current source means, anyone tell me what is the name of the current source? Transistor. So they will not ask you what is the name of current source. They will say solve the circuits using the current source. Next, KVL and KCL. Now you see all of you in our subject, KVL means mesh analysis and KCL means which analysis? Anyone tell me? Nodal analysis. Now you see analysis of simple circuits with DC excitation. Excitation means battery. That means circuits we have done. Analysis means solving the circuits. Analysis means it is not any theory question. It is the problems. We have done the problems on mesh analysis, nodal analysis, and next theorems. Okay, next topic, what it is there, all of you?
Superposition.
Superposition. Now you tell me, superposition theorem. If I want to use the superposition theorem, minimum how many sources should be present?
3 elements.
Two sources, minimum 2. Yes or no? Minimum 2. If I am having one source, I cannot use the superposition theorem. If I am having the one source, I cannot use the see chat box. All of you check the chat box. I am not understanding. Okay. See. See, chat box, certain people are communicating, that is not professional. Okay, right. So superposition theorem, if I'm having one source, I cannot use the superposition theorem. Minimum 2 sources should be there. And tell me, all students are perfect with superposition theorems, what we have done?
Yes, sir.
That's enough. Okay, right. Now, next comes the Thevenin's and Norton's theorems. Okay. Now, what is this topic? Time domain analysis of first order, RL and RC. So this topic actually it belongs to the second unit. This will take along with the second unit. Understood all of you? All the students. So in the first unit, what you are supposed to see, all YouTube links are shared to you. Okay. and what documents are shared to you. Hmm. See, this the people who are disturbing, they are called the terrorists actually. Right. Okay. Now you tell me, all of you, unit 1, what we are having? Mesh analysis, nodal analysis, superposition,
Superposition theorem.
Thevenin's and
Thevenin's.
Norton's. Okay. So next class in the new year, we are going to start the unit 2, which is which circuits, all of you? AC. AC means what? Already I mentioned alternating current. Alternating current. Okay, what is alternating current? And this is the huge unit. Okay, it takes time, and then we'll slowly discuss all the topics. Now, any questions you are having, you go ahead, ask the question. And what are the circuits we are doing in the classroom? That's enough for the examination. After our completion of in the revision part, I will take different circuits. Now, you should, on 24 hours, you must be in a position to solve the circuit. Now, ask the any question. Any question you got? Any student? Go ahead. So be perfect with mesh analysis first. Mesh analysis notes is there in all of you document. I've given 4 to 5 circuits. How to solve any circuit. Okay. Right. So that's enough for the first unit. Next tomorrow onwards, we are going to start the second unit, which is AC current, which is very much tough. We should work with the calci there also. Okay. Any question, anyone? Just go ahead, ask me. Okay. So be prepared. I'll keep the online exam. Yes.
Okay, sir.
Yesterday and yeah, one second. One Suchitra student is asking. See, I'm sending every day. Yesterday's also it is there. Yesterday, what we have discussed, Thevenin's theorem, it was shared. Suchitra, you see that? Okay, you'll get that one. Today's also evening I'll share. Okay, right. Okay then. I'm just ending the class. Any question is there, you can ask. Remaining students can leave. Students who are having any question, they can ask. Okay.
Sir,
Yeah. Just ask. Yeah.
on superposition, you didn't send it any problem, sir.
Okay. Are you CSC?
Yes, sir, CSC.
Okay. Is Prasanna is there online? The student Prasanna? Okay. Superposition theorem. One second. Superposition theorem material is Prasanna is there online right now? Okay. What is your name? I'll just forward to you. Superposition theorem.
Sir, please forward in group, sir.
Group. Okay. See, sudden.
Yes, sir, in group you.
Okay. See, all of you.
Yes, sir.
One student today, you text me. I will not forward the material in the group directly because those materials are confidential. Okay. So 2 students only I will be forwarding. That is the first point. So the student who's asking the materials, which material? Superposition theorem? PDF.
Yes, sir.
Okay, one student you message me right now. I just forward within a second. Okay, and all of you can share yourself. There is another students group. No, in that you can have. Okay, one student you message me right now. Okay, regarding what you want, the superposition theorem document. I'll send the PDF and the YouTube link. Okay.
Okay, sir.
Okay, right. So everyday materials you are getting, no, all of you. Thevenin's theorem you got, all the students, those who are there online.
Yes, sir. Yes, sir.
Okay. So you just message, I'll send that one. Okay, right. Thank you.
Sir.
Yeah.